Hi, Trig students, and welcome. I have no idea if you can see me on my webcam or not, but if you can, the reason I look ridiculous is because this was my Halloween costume, but as the day's gone on, I kind of got rid of some of my accessories, including my mask that matches oh so perfectly. But today, after you finish up your test, I just wanted to quickly go over with you some of the fundamental trig identities we're going to be using in Chapter 5 as we move on. Now, you might be like, Miss Taylor, I just took a test on Unit 3. You are absolutely correct. We are going to be skipping Unit 4 right now, which is about graphing trig functions. We're going to move on to graphing at the end of the semester if we have time for it. But I personally think that fundamental trig identities and verifying trig identities, which is what we do in Unit 5, is a more important concept for you to learn if we are shorter on time. So today in this video, we're going to discuss some of our trig identities that we will be using throughout Unit 5. The 4 types of identities we're discussing today, and there are more, but these are the 4 we're going to start with, are reciprocal, quotient, Pythagorean, and negative angle identities. So before we jump in and I start writing, I'm going to pause the video or, pop up a question here. What does the word reciprocal mean? So hopefully you had time to answer that question. Reciprocal means multiplicative inverse. So we want to come up with a fraction that we could multiply by our original trig function and just get 1 as our identity. When we talk about trig functions, the ones that we know the reciprocals of best are probably actually the more niche trig functions, which would be cosecant, secant, and cotangent. And you're probably like, Miss Taylor, why are we starting with the harder ones? But this is why. Cosecant is the reciprocal, as you hopefully remember, as 1 over sine. That makes secant be the reciprocal. Remember, secant went with cosine, so secant is the reciprocal of cosine. And cotangent, I bet you can do this one on your own. In fact, I'm going to have you type in your answer to cotangent right now. That's right. Cotangent is going to be 1 over tangent. Now, you can also look at these in the other way. So you could start with sine, and you could write the sine as 1 over cosecant. And I bet you can finish off for cosine and tangent. So I'm going to give you time right now. I don't know if I can ask 2 questions at once. So if not, you'll have 1 question, then immediately after another question. What is the cosine of theta? And what is the tangent of theta for the reciprocal? What is the reciprocal identity for those? So cosine, 1 over secant, and tangent, 1 over cotangent. So pretty straightforward. Hopefully, at least the first 3 you are familiar with. The next 3, hopefully you can get there using logic. Quotient identities, that's the next group of identities we're going to learn today. And by we're learning today, you already know this one. We've been using these. We just didn't give them a name. And so quotient identities, I want you to think about tangent. When we talked about the unit circle specifically, we use this quotient a lot. Tangent, as we've discussed, is y over x. And on the unit circle, that is sine over cosine. All right, so my question for you that you're going to answer on the screen here, what is our reciprocal of cotangent? Or I'm sorry, not reciprocal. What is a quotient? Sorry, what is a quotient of cotangent? What is a quotient identity? That's right, cosine over sine. It would have been x over y. Perfect. Okay, moving forward, the next thing we're going to discuss today is the Pythagorean identities. So for our Pythagorean identities, think about the Pythagorean theorem that we focused on a few times in this course. So a squared plus b squared equals c squared. And remember how we related that to our unit circle. And we talked about how that was x squared plus y squared equals r squared. Even more specifically, x could be written as cosine, and y could be written as sine, and on the unit circle, your radius is just 1. So our Pythagorean identities, this is our first Pythagorean identity, is cosine squared plus sine squared equals 1. Oh, I forgot my squared, I'm sorry. You'll see this written in a lot of different formats. Sometimes you'll see it written with sine squared first and then cosine. You can also see this written as solved for sine squared. So if you wanted to subtract cosine squared from each side and just get sine squared completely by itself. And sometimes you'll see it solved for cosine squared. So 1 minus sine squared. And then again, sometimes you see it written as sine squared first plus cosine squared second equals 1. So those are all different variations of the same Pythagorean identity. And we actually take this Pythagorean identity and we create additional Pythagorean identities using different trig functions. So if we wanted to create another Pythagorean identity, let's think of a way that we could get a tangent. So let's say we want a tangent somewhere in our trig function. And the reason we would want this is, let's say we have an identity problem, and instead of having sines and cosines, we have tangents and some other trig identity. So we know that tangent is sine divided by cosine. So tangent squared can be sine squared divided by cosine squared. So if we divided every single term here, sorry, not by sine, we want to divide every single term here by cosine squared. Divide that by cosine squared. Divide this by cosine squared. We're going to end up with our second Pythagorean identity, which cosine squared divided by cosine squared. What does that simplify to? I'll give you a question now. Cosine squared divided by cosine squared. Perfect. That simplifies down just to 1. Then we have sine squared divided by cosine squared. So sine over cosine. That simplifies down to tangent squared. And 1 over cosine is going to give us a secant squared. So that's our second Pythagorean identity. And again, you can see this in multiple formats. You might see it as 1 equals secant squared minus tangent squared if we want to solve it for 1. We might solve it for tangent squared and see this written as tangent squared equals secant squared minus 1. So lots of options here. But that would be our second trig Pythagorean identity. If we wanted to find our third Pythagorean identity, that's going to involve us taking our original Pythagorean identity, so sine squared plus cosine squared. And instead, this time, let's divide everything by cosine. So dividing everything by cosine squared. I'm sorry, we already divided everything by cosine squared. What am I doing? Sorry, we want to divide everything by sine squared. Divide everything by sine squared. You would be like, Miss Taylor, we're going to get the same thing. I apologize. Sine squared, divide everything by sine squared. That gives us our third Pythagorean identity. So sine squared divided by sine squared, that simplifies down just to 1. What is cosine squared divided by sine squared simplify down to? I'm going to give that to you as a question. Cosine divided by sine, what does that become? Exactly from above, cotangent squared theta. Perfect. And then 1 divided by sine squared is going to give us cosecant squared. Use that reciprocal identity from above. So that would be our third Pythagorean identity. And again, you sometimes see this written in different formats. So you might see this as cosecant squared minus cotangent squared equals 1. You might also see this as cotangent squared is cosecant minus 1 as well. Okay, so lots of different options of formats you can see it in, but I want you to be familiar with what I'm highlighting. So what's already in yellow plus what I just highlighted in blue plus what I just highlighted in green These are your three main Pythagorean identities, and the other formats that I have written off to the right-hand side here, those are just different variations of the same identities. Alrighty. The final thing I want to talk about in today's video is negative angle identities. So discussing when you have a negative angle, if that impacts the sign, like positive or negative, not SINE, but if that impacts the sign of your trig function. So we're going to start off first looking at this picture. And in this picture, they are looking at what happens if you take the sine of a negative angle. So remember, negative angles, when we take negative angles, instead of what we normally do, starting at the positive end of the x-axis and going counterclockwise, we actually go clockwise. And I want you to notice on this picture, when we're doing the sine of a negative angle, that would give us the ratio. Look at this triangle that it creates right here. That would give us negative y over r. And remember that sine is typically positive y over r. So this means this would be giving us the opposite of what we currently get. So remember, a negative sign typically means opposite. And so remember, sine goes with cosecant. So that means our cosecant of a negative angle would also then make a negative cosecant. Because think we're just doing r divided by negative y instead of negative y divided by r. The next piece I want you to think about is cosine. So remember, cosine deals with your x's. If we are on the unit circle and we are looking at our ratio again, remember our ratio for cosine would be x over r. So even when we have a negative angle measure, notice that it's still just an x. So it'd still be x over r. So the cosine of a negative angle is actually the same as the cosine of a positive angle. Similarly then, if we're taking the secant, so if we're flipping our fraction, that doesn't change, that it's still a positive secant. So secant theta. So the final thing you want to think about is tangent and cotangent. So thinking about tangent, remember tangent is what ratio? Type in the question here. What is the ratio for tangent? You could have done multiple things. You could have done x over r, or I'm sorry, you could have done y over x. You could have done sine over cosine. But think about what we have here. We would have had a negative sine over a positive cosine. Obviously, that's going to make a negative tangent, right? A positive divided by a negative is going to make us a negative, which means this will be up for you. Your question, what will cotangent of a negative angle simplify down to? Perfect, negative cotangent. So I know we haven't actually done any problems yet. I wanted to go through with you in this video and go through these specific different identities we're going to be using throughout the chapter, because now when you come to class on Monday, you're going to be prepared. You're going to have seen these before. So when I start using them, we're not going to have to go through and derive them again and explain how they came to be. So thank you for participating in my first Edpuzzle. I look forward to seeing you in class on Monday.